Hi all, my name is Álvaro Bautista and I'm part of the Gulf Coast Research and Educational Center Horticultural Lab. And I'm honored to be here to explain you how localized root zone compost application improves the establishment and the yield of tomatoes in a subtropical sandy soil. It is well known that Florida soil is mainly sandy soil. This type of soil is characterized by being a very thick particle with large pores within it. This produces or poor retention of water and nutrient. Also, a very low organic matter. A great solution to this problem is to apply compost to our soils. By doing this, we will be addressing the water and the nutrient retention that the sandy soils are lacking. Also, we will provide organic matter that creates an incredible environment for beneficial microorganisms. Although there are some factors that are limiting the use of compost. First, fast decomposition due to the high temperatures. This rapid decomposition leads to a fast release of nutrients that most of the time cannot be absorbed entirely for the plants. Instead, they are being lost to the environment. A second factor is the elevated cost of applying big amounts of compost. Because of the way of applying compost currently is to incorporating directly to the soil. So why don't we apply compost directly to the planting hole? By doing this, we will be maximizing the root compost contact. Therefore, the nutrient use efficiency will be increased, and also will be reducing the amount of compost applied. Before getting into further detail, let me explain you how fertilizers are being applied in a commercial field for tomatoes in Florida. Everything starts with a soil incorporation of 56 kg nitrogen per hectare. Once the bed is formed, a tractor proceeds to create two narrow ditches which are going to be filled with 78 kg of nitrogen per hectare. Finally, 110 kg of nitrogen per hectare are being applied directly to the irrigation system from week 5 to week 11. Our 2021 fall season trial was conducted by using fresh market tomatoes from the variety HM1823, planted on a 97% sandy soil in west central Florida. Our experimental design was a split plot design with 3 nitrogen pre-plant incorporation rate as our main plot factor, 0, 28, and 56 kg of nitrogen per hectare. 4 compost planting hole application rates as our subplot factor, 0, 10, 20, and 40% of the planting hole filled with compost that represent 0, 1, 3, and 6 kg of nitrogen per hectare respectively. In this table, we can have a better representation of our treatments. In the column on the left, we have our 3 different nitrogen pre-plant incorporation rates, 0, 28, and 56 kg of nitrogen per hectare. Following to the right, we have our 4 different compost planting hole application rates, 0, 1, 3, and 6 kg of nitrogen per hectare. It is also important to point out that the growing commercial standards in a commercial field for tomatoes, 244 kg of nitrogen per hectare are being applied in total during the farming season. So first we wanted to know if our compost application had a localized root zone effect on our plants. In order to do that, we measured the soil electric conductivity directly to the planting hole and 5 centimeters from the planting hole. We found out that directly at the planting hole we had a significant trend where the higher the compost treatment, the higher the soil EC value. Although at 5 centimeters from the planting hole there was no trend or there was no significant difference among the treatments. Instead, the soil EC value were very low. We then proceed to take overhead photos of the canopy of each plot in a weekly basis. These images were then analyzed in the free software ImageShade, where we obtained a binary image in black and white from which we got a canopy projected area measurement. The canopy projected area at 14 days after transplant showed us that the plants where compost was added, no matter the application rate, performed with a higher canopy projected area. The nitrogen pre-plant incorporation was consistent among the treatments, therefore it had no influence on the canopy projected area by itself, although the interaction between compost and nitrogen incorporation showed us that by applying 0 kilograms of nitrogen per hectare incorporated, we can achieve an 110% increase of the canopy projected area from no compost versus adding 3 kilograms of nitrogen per hectare of compost. The following treatments with 28 and 56 kilograms also showed us this trend, although its value of increase was less. It is also important to outstand that by applying 3 kilograms of nitrogen per hectare with no nitrogen incorporated to the bed, we achieve an increase of 19% of the canopy projected area versus the commercial growing standards. Our marketable yield data showed us that the plots where compost was applied, these plots achieved higher extra large size fruit and less medium sized fruit in comparison with plots with no compost added. Also, by applying 3 kilograms of nitrogen per hectare versus applying 0, we can achieve a 17% increase of the total marketable yield. Although there was no significant difference between the interaction of the nitrogen pre-plant incorporation and the compost planting hole application, it is safe to say that we can achieve a slightly higher yield on the 3 kilograms nitrogen per hectare with no pre-plant nitrogen incorporation rates versus the commercial growing standards. Overall, by applying 3 kilograms of nitrogen per hectare from compost directly to the planting hole, we can achieve an increase of 19% of the canopy projected area and with a slightly numerical higher marketable yield production by applying 22% less nitrogen per hectare versus the commercial growing standards. In conclusion, these results suggest that the compost planting hole application is a highly effective strategy to improve the efficacy of compost in a subtropical sandy soil. This new compost application method can enhance tomato establishment and yield while minimizing the use of pre-plant nitrogen fertilizer. And a special thanks to our collaborator Live Soils for providing compost to run this experiment, and of course to our incredible horticultural lab staff. Thank you very much for your attention, and I hope you like this presentation.